I'm Dr. Devi. In underground cable engineering, the fifth topic in the fourth unit is polymeric insulated cables for transmission voltages. Traditionally, high voltage transmission is used only for insulated cables. But with advancement in insulation materials like cross-linked polyethylene and other polymer materials have become the standard for extra high voltage and ultra high voltage transmission systems. These cables offer reliability, layer maintenance, and environmental benefits compared to oil-filled systems. And this diagram represents the transmission cables. The construction of polymeric transmission cables are pressure fluid filled, which of type of cables are used mainly in North America. The insulated conductors are drawn into steel pipe, which is subsequently filled with liquid and maintained under a high pressure. The basic principle of HPF of cable is same as that of fluid filled cable, that is, the insulation is kept fully impregnated at all times. The construction of polymeric transmission cables in order to reduce drainage of fluid from the insulation during transit from the factory to site, the cable is impregnated with an impregnant which has much higher viscosity than that used for SAF cable. HPF cables are at present in operation at voltages up to 550 kV. The amount at the maximum voltage is very limited, and the highest voltage at the significant quantities of cable have been installed is 344 kV. Cables have been developed for 765 kV operation. The conductors used in this type of cables are both aluminium and copper conductors are used up to maximum conductor size of approximately 1250 millimeter. Larger sizes are generally not economic because the closeness of the pores in the pipe gives rise to the high proximity loss in the conductor, which significantly increases the AC resistance. The second one is insulation. The requirement for the insulating papers and lapping are generally similar to those of ACF cables. In case of HPF cables, there is an additional requirement for a very fine insulation to minimize deformation due to the side pressures which occur during installation, as previously mentioned. The electrical characteristics of this type of cables are represented in this graph. The polymeric insulating materials used are cross-linked polyethylene and the ethylene propylene rubber. The next one is steel equipment installation. The pipes are made up of carbon steel, complying with the appropriate national standards for thickness and testing requirements. It is important to avoid an internal diameter of the pipe of three times the diameter of individual pores, as it is possible for the pores to align across the diameter and jam during the pulling in operation. This table provides the comparison of various transmission cables. The different techniques which is used to increase the current carrying capacity are: the first one is improving conductor properties. The rule of increasing the current carrying capacity is represented in this diagram. This diagram represents the most common gauge size. The second point for increasing the current capacity is enhancing insulation of dielectric materials. The third one is thermal management. Fourth one is using optimized insulation methods. Fifth one is advanced cable designs. Next one is operational techniques. Simply, we can say to increase the current carrying capacity, engineers either reduce resistive heating, improve insulation and cooling, or use advanced technologies like fluid-filled, superconducting, or dynamically rated cables. Transmission cable accessories and joining for pressure assisted and polymer cables. This diagram shows the joining as well as accessories for the pressure assisted and polymer cables. The joining arrangements for transmission cables. The first diagram represents the pressure assisted cables which has straight jump. The second diagram shows the transition joint for the polymer cables. Then, in this slide, the first diagram represents the pressure sealed termination for the pressure resistive cables. The second diagram shows stress cone terminations for the polymeric cables. The cable accessories. The first one, pressure resistive cables, use gas pressure cables and high pressure oil filled cables. Uses the accessories of terminations, pressure tanks, pressure monitoring alarms, and the stop joints. There are various joining methods for pressure assisted cables are straight joints, stop joints, and sealing techniques. There are different types of accessories used in polymeric insulated cables are outdoor indoor terminations, joints, sealing, and to protection. The varieties of joining methods for the polymeric insulated cables are straight joints, transition joints, and bonding joints. This table provides the comparison of the various insulating mediums, terminations, joint, and monitoring complexity as well as reliability of pressure resistant cables as well as polymeric cables.